Hello friends, I'm Sarita Verma and once again welcome to my channel Electronics and Life Simplified. In this video series of Basic Electronics Engineering, today we will discuss about a very special type of diode called light emitting diode, often called LED. This video has been designed with the objective that after watching this video, viewers should be able to draw the symbol of LED, explain the construction and working of LED, define the various parameters of LED, plot the characteristics, as well as compare the different types of LEDs, as well as diodes. So let us see what is a light emitting diode. It is also again a PN junction diode which emits light when forward biased. The emitted light may be visible or invisible, and the amount of light which is radiated from this diode, this is directly proportional to the forward current. So your LED has two terminals, anode and cathode. This is the symbol of the LED. Here you can see from the anode we have shown light rays being emitted, and the cathode is in the form of a bar. Physically, if you see, the anode terminal of the LED is longer than the cathode. Let's see the construction of LED. Yes, the material used in the construction of LED is quite different from our normal PN junction diode. Here, an N-type layer is grown on a P-type substrate by diffusion process. A thin layer of P-type is grown on this N-type layer. The metal connections to both the layers to make the anode and cathode terminals are taken. Light energy is released, we know, at the junction when the whole electron recombination takes place in case of LEDs, whereas in normal PN junction diodes, heat is radiated. And after passing through the P region, the light is emitted through the window provided at the top of the surface. Let us see the working of LED. We know that LED is operated always in the forward bias condition. That is, the P-type material is connected to the positive terminal of the battery and the N-type semiconductor is connected to the negative terminal. And when the LED is forward biased, the electrons and holes move towards the junction and whole electron recombination takes place. When this recombination takes place, the recombining electrons and holes radiate energy in the form of light. The difference of energy between the conduction band and the valence band is radiated in the form of light energy. That is the energy which it had absorbed while moving from the valence band to the conduction band. The same energy is radiated by the electron when it is moving back from the conduction band into the valence band in the form of light. In ordinary diodes, this energy is radiated in the form of heat when whole electron recombination takes place. So in both, whole electron recombination takes place. In normal diodes, heat is radiated, whereas in LEDs, light is radiated. There is a basic difference in the materials which are used in the construction. For PN junction diode, we know that germanium and silicon are more commonly used, whereas for LEDs, since they radiate light in different colors, red, green, yellow, blue, orange, and so on, some LEDs even emit light which is not visible to the eyes. The color of emitted light depends upon the type of semiconductor material used. So the commonly used materials in the construction of LED are gallium arsenide, gallium phosphide, gallium arsenide phosphide, and gallium nitride, which is used, which helps in radiating blue light. So gallium arsenide, the light which is radiated using these materials is infrared. Gallium arsenide phosphide, red to infrared orange color is also radiated. Aluminum gallium arsenide phosphide, high brightness red, orange and yellow radiations of light can be emitted. Gallium phosphide, It is used for red, yellow, and green. And this is the list of different combinations of material used for radiating different colors of light. Here is again a typical LED characteristics, that is semiconductor material which is used, the wavelength of light which is radiated, the color of LED, along with the forward voltage which is to be applied, and the current that is which flows through the LED, along with the materials used in the construction. These are the steps involved. LED is connected in forward bias condition, and whenever the current flows in the forward bias condition, light will be emitted. The flow of current is because of the movement of electrons. The recombination shows that the electrons move from the conduction band back to the valence band, and when they move back, they radiate energy in the form of light or photons. The energy of photons is equal to the gap between the valence band and the conduction band. Let us see the characteristics of it. This is the characteristic curve for the LED, which shows that the forward bias of just around 1 volt is sufficient to increase the current exponentially in case of LED. So very little voltage is needed for the current to flow through the LED. These are the few advantages of LED. LEDs are used, have many advantages. That is, they are small in size, light and weight, they are available in different colors, the intensity of light can be controlled smoothly. Then they have a very fast switching time in nanoseconds. They are very economical, very of low cost. They have a high degree of reliability. They can be operated for a wide range of temperature, and they consume very less power. LEDs also have a very high efficiency. So these are the few advantages. LEDs also have a few disadvantages: over voltage or over current. Due to that, the LEDs may get damaged when the current is increased beyond a certain limit. Overheating due to radiant power may also damage the LED. They require moderate power for operation. Typically, the voltage range is very small, 1.2 volts, and the current of 20 milliampere is sufficient to provide full brightness. The LEDs consume more power as compared to LCD, and it is not used for making large displays because of the more power consumption. Here are a few applications related with LED. They can be used for TV backlighting, used for displays, used in automotives, for dimming of lights, alphanumeric displays, lighting, decoration. It has made the world very beautiful because they are used in most of the decorations, in marriages, in different functions, and you can, whenever you visit an airport or railway platform, you can see rolling displays even in bank counters, and the LEDs play a very important role. So the list of applications of LED is huge. Here is a small quiz for you to solve and just recap. A light emitting diode is operated in dash bias condition. Yes, we know that it is always operated in forward bias condition. A light emitting diode requires very low voltage, and current increases exponentially. So it has to be very heavily doped. The material which is used to produce infrared LED is gallium arsenide. The reverse breakdown voltage of LED is very low. True or false? Yes. Breakdown voltage is low. And which process of electron-hole recombination is responsible? So, of course, it is a hole electron recombination. And here is the list of answers for your reference. Thank you.